All right. Hello, class. Uh, let's see. Here's your exam from last time. The goal here is to factor, and we mean factor completely. I graded your exam. Most of y'all got this. Some of y'all came close. So let's keep working on this factoring here. When I see something like this, the first thing I do is I go for a GCF. I look at the coefficients, the numbers out front. Since this one just has a 1, not a lot we can factor out here. This one doesn't have a y, so there really is no GCF here. Next thing I do is I try to factor by grouping. I look at this and this separately. Out of the first couple of terms, I could pull a y squared out. That leaves me with a y plus 6. And then I hope that I can turn this into something times y plus 6, just like this one. If I can, then I can factor by grouping. And it turns out if I pull out a minus 4, I get a y plus 6, which is convenient, right? This doesn't always happen. This just happened to be one where we can factor by grouping. So we have a y squared minus 4, both times a y plus 6. And since we have this squared going on here, we might look at this and say, well, can we factor this further? And this is the difference of two squares. So we can write it as a y minus 2 times a y plus 2. All right, there's our minus 4. There's our y squared. The minus 2y and the positive 2y cancel each other out. And then we are done. And the next one is similar. We look for GCF. The coefficients here, these have 1s, so you can't really pull out any numbers. This one doesn't have a c in it, so we can't pull out any c's. So first off, we attempt grouping, and we hope that it will work. Out of the first two terms, I can pull a c squared out. That'll give me a c minus 1. So I'm hoping that I can turn this into something times c minus 1. And if I pull out a minus 25, I get exactly that. I get a c minus 1. So that leaves me with a c squared minus 25, both multiplied by a c minus 1. And this, with the squared in it, tells us we might want to see if we can factor that. And it is the difference of two squares. 25 is 5 squared. So this is c minus 5 and c plus 5. And at this point, we are done. We can just box our answer. Okay. So that's it for the exam. Any questions? All right, here's the quiz for today. It's a little bit harder, but it still follows the same patterns. But like say number 1 here, you can't really get a GCF out. This doesn't have x's or y's. And so what this is, it has x's and y's. This is really, you could call it u squared, where u is x times y, if you wanted to. But you might be able to factor this by grouping. I haven't looked at it yet, but that's the approach I would take. Since we have 4 terms, I would try grouping like we did on the exam. Let's take 10 minutes to 15. We will work this together. Okay, class, we're back. Let's see what we can do with this quiz here. Oh, I graded your exams. They look good. We're going to start doing review today, and some of y'all are still missing some quizzes and exams. Make sure you get those turned in. The solution's already posted, so it's real easy to get half credit. All right, I don't want to see any zeros. Y'all are my best class. Man, my business class sucks. I only have 6 students turning in their work, and I do all their work in class. So it's rather disappointing. All right. But y'all are doing great. I'm proud of y'all. So keep up the good work and make sure by the end of this semester you don't have any zeros, okay? And I want to see y'all make A's in this class. All right, let's look at this thing. We could do some grouping here. Let's see if it'll work. I don't know if it will or not. Out of these first two terms, I can get an x squared out of there. And that leaves me with a y squared minus 9. So if I can turn this into something times y squared minus 9, then we're grooving here. I need to get the y squared, so why not try a minus 4? That would give me my y squared. And minus 4 times minus 9 is positive 36. So that works great. So we have an x squared and a minus 4 times a y squared minus 9. Now, since these things have squareds in them, I need to look at them and see if I can factor them further. This dude is the difference of two squares. 4 is 2 squared. So this dude is x minus 2 times x plus 2. And this dude here is also the difference of two squares. 9 is 3 squared. So I can rewrite that guy as a y minus 3 times a y plus 3. Boom. We are factored. Okay. Any questions about that one? Okay. Let's look at number 2 here. First, I look for a GCF. There's no numbers here, so I can't get any numbers out. And this dude doesn't have any W's or Z's, so no GCF. Let's try grouping again. The first two terms, I can get a W squared out of there. So that would leave me with a Z squared minus 1. And now if I could turn this into a Z squared minus 1, I'm good to go. This looks familiar. Did we just do this one? 1 out of 25. Oh, it's just like this one. All right, we're going to pull out a minus 25. That's going to give us a Z squared minus 1. So I have W squared and a negative 25, both times Z squared minus 1. Since these both have squares in them, I need to see if I can factor them further. This dude is the difference of two squares. 25 is 5 squared, so I can rewrite this as W minus 5 and W plus 5. And this guy here is also the difference of two squares. 1 is 1 squared. So I can write this as a Z minus 1 times a Z plus 1. Boom, we are done. Any questions? I know there's a lot of letters and stuff here, but with practice, you'll get this down, okay? Hopefully in college algebra, you'll have this mastered, all right, where you can just do this reflexively. That's the goal. So moving on, I have this review. It's from a different class, but it's real close to what y'all's class is. It's 0410, y'all 0415. It's the same class, but not the STEM version, but it's a good place to start for a review. All right, so let's, so we're going back to easy stuff here, but I figure we can go through this review. And then we will hit the sections and start working problems out of the sections. All right, so some of these chapters, I think it's the same book, but it might be a little different, okay? I think we covered more chapters in your class than we did in this class, so we'll see though. We'll figure it out over this next 3 weeks. Well, 2 weeks, because Thanksgiving, right? The sun coming in here. Okay, so we need to use the greater than or less than. All right, so quick recap. Remember your number line. This is your greater than symbol. This is your less than symbol. Right? Just think about your number line. Forget about little alligators eating big alligators or whatever the crap. Okay. So -3 is less than 2. 7 is less than 9. -4 is less than -2. All right, does this make sense? Not something you want to get confused. Okay. So your final will look something like this. It's going to be like, here, I'll show you a sneak peek. There's number 1 that has a few parts, and there's an A and a B, and each A and B has a few parts, right? There'll be a number 2 with multiple parts. This one has A, B, C, and D in it. You'll have number 3. Basically, you're going to have 11 problems on your final, and each one's worth 10 points. So you can get up to 110 on the final. So it's kind of like having an extra credit problem, but I'm not designated any one to be the extra credit one. You can just get an extra 10 points. Let's look at B here. So here it's just basic arithmetic. We want to simplify. So -2 times 3 is a -6. And then a -6 plus 1 is a -5. Over here we have 6 plus 2 squared is 4. 4 times 3 is 12. 6 and 12 is 18. Over here, let's see. 3 minus 2 would be 1. 3 plus 1 is 4. 4 squared is 16. And 1 minus 16 would be -15. Okay? And it makes it a lot easier when you box your answers, right? You can plug this in a calculator and write this down, but you'll lose points. Show your work, all right? There's no work to show up here. It's kind of like a 50-50 chance you're going to get it right just by guessing, all right? But you need to show your work. Wrong spot. There's part B, part C here. All right, so more simplification. So we have 2 plus 3 squared is 9. All right, 2 plus 9 is 11, minus 1 is 10. 10 divided by 5 is 2. All right, part 2 here, the absolute value of -3. Remember, absolute value is its distance from 0. So -3 is a distance 3 from 0. 3 plus 1 is 4. 4 divided by 2 is 2. All right, so this is what your work should look like. I know you might be able to do this in your head. Show your work so that I know you're not just punching it into a calculator, okay? Over here, there's x's. So what? 1x plus 2x gives us 3x's. 3's cancel, and we just get an x. Clicking on the wrong thing. Here's some rounding. Okay, so not a lot of work to show here. This is one where you just give your answer. Let's see, 2 decimal places. This would be 3 point. The 1 leaves the 4 alone. Over here we have -1 point. Let's see, the 9 will turn the 3 into a 4. All right, this one's a little trickier. Let's see. This 9 turns that 9 into a 10, which turns that 2 into a 3. So you would have a 3.30, and you have to have that 0 there, okay? Because that's what tells you about all these other 9s over here, basically. You have to have that 0 there. It's not just 3.3 because we need 2 decimal places. Okay, that 0 contains information. Yeah, I'm so glad I have y'all's class. My other ones are so disappointing. All right. No matter how many quizzes or exams you're missing, if you're here today and you haven't given up, you can still make an A in this class. Just do the work. Okay. Do the best you can. Don't give up. All right. Find the prime factorization. All right. If y'all remember, this is where you bust these numbers down into products of prime. So I always start with 2. If it's even, see, 90 is 2 times 45. 45 is what, 9 times 5? Then 9 is 3 times 3. Just check our work here. 6 times 3 is 18. 18 times 5 is at 90. I don't know. Let's see. 9 times 5 is 45. Times 2 is 90. Yeah. So I would rewrite this as 2 times 3 squared times 5. That's the best way to write it. Sure, these are equal. Technically, this is okay. But this is what we're looking for. This is the pretty version, right? You want them in order from lowest to greatest. Make sure all these numbers are prime numbers and write them as exponents. 88 is 2 times 44. 44 is 2 times 22. 22 is 2 times 11. I write this as 2 cubed times 11. Okay, so here, yes, this is how I'm showing my work. 250, that's 2 times 125. 125, let's see. How many times does 5 go into 125? Let's see, I got a 2, and bring down a 5, right? And 5. Yeah, 20, so yeah, that gives me, no, yeah, 25. So, 250 is 2 times 125, and 125 is 5 times 25, and 25 is 5 times 5. Let's check our work. 25 times 5 is 125, times 2 is 250. I would rewrite this as 2 times 5 cubed. All right? You stop me if you have questions. I would like constantly ask you if you have questions, but nobody ever answers. So I'm going to move on with it. Here's more simplifying. Part B here. All right, over here we need a common denominator. So I would multiply this first thing by a 2 over a 2. All right. That gives me 36 and 8/6. All right, so I have 38/6. And then I can simplify this. This is a 2 and a 3 in it. So this thing I'm going to write as 2, what is it, 2 times 19? Is that right? Yeah. This is a 2 times 3. This is 19 thirds. All right, you could write it, do more work and write it as a whole number plus some other stuff. That's not necessary. This is fine. Okay. All right, if you wanted the 18, you could write this as what? 18 plus 1. And 18 divided by 3 is 6 and a third. Either one of these answers would be acceptable, but this is good enough here. This guy is pretty simple, right? You can get rid of the x's. 10 is 2 times 5. We got 5y. But you could probably look at this and write that down, right? But again, show a little bit of work, but I know you're not just typing it into a calculator, right? You could look at it and go 5y. Boom. Over here, we could do this in our head. 4 divided by 2 is 2. The a's, there's a cubed over a, and the a to the 4th over a gives us a cubed, and there's a b on the bottom, right? So you should be able to write the answer down. If you want to show some work, write 4 is 2 times 2. If you wanted to, you could do this. But you can easily cancel them out. So it gives you the 2a cubed over b. All right, let's see, what do we have? Negative 2 times 4 is a negative 8. 3 times 6 is 18. Let's see. 8 is 2 times 2 times 2. 18 is 2 times 9. That gives us a negative 4/9. This guy up here, we need to multiply this out. So let's see. 2x times 1, 2x. 2x times a negative 3 is negative 6x. And then we have 7x, right? Everything on the top and the bottom has an x in it, right? Really, you could just do this from the start, okay? But if you wanted to do it this way, you could go, okay, this is 2 minus 6, both times an x. 2 minus 6 is a negative 4/7. Which you could probably do from right here. You'd be like, okay, this is negative 2. Right? That'd probably be a smarter way to do it, right? Let's do it. Or do it the smarter way. 1 minus 3 is a negative 2. And then you could go boom, boom. So 2 times negative 2 is a negative 4/7. So there's another approach to doing it, right? A little bit quicker. But again, you could do it in your head by doing that. Negative 2 times 2 is negative 4 divided by 7. Over here, let's see. Get rid of these x's. 6 times a negative 3 is negative 18 over y squared. So the only work here to show is this, right? Or if you wanted to show more work, you could be like, this is negative 18x over x y squared, right? And then go boop, boop. Right, if you wanted to show a step in there. I mean, there's an art to doing math in your head. There's also an art to showing what's going on in your head, right? Basically, that's what we're doing here. Just because you can do it in your head doesn't mean that you want to be able to write down what you did in your head, no matter how simple a task it was, okay? Because this is what we did in our head. We said, this is 18 with a minus, and then this gives us y squared. That's what we did in our head. And it's good to be able to write that down, because some things you can't do in your head, and you want to have the art of being able to write down what's in your head down well, so you're good at it for when you can't do it in your head. Look at the next one here. Simplify. Ew, this one's awful. I'm going to need a common denominator, right? What's the smallest number that all three of these divide into? Take a 12. So I'm aiming for 12. To turn the 2 into a 12, I'll do a 6 here. To turn the 4 into a 12, and multiply it by 3. And turn the 6 into a 12, and multiply it by 2. So here I have 6 twelfths, 9 twelfths, and 10 twelfths. 6 and 9 is 15, plus 10 is 25 twelfths. Can we simplify this? This is 5 times 5. This is 2 times 2 times 3. So we can't simplify that. course, if you wanted to, you could write it as 24 plus 1/12. This would be 2 and a 12th. But this is good enough here. Part 2, let's see. Well, we might look at that and think it's the same as this, but we have a division symbol right here. Dividing by a fraction is the same as multiplying by its reciprocal. We have a 4, 6, and 5, 6, because we're just multiplying the tops across, which gives us 9, 6. 6. Again, 9 is 3 times 3. 6 is 2 times 3. So we get 3 halves. Let's see, over here, we have this division again. We need to tend to it first. Dividing by a fraction is the same as multiplying by its reciprocal. We have a negative 18/20. So to get a common denominator, I'm going to turn that 2 into a 20. This gives me 10 minus 18/20, or negative 8/20. 8 is 2 times 2 times 2. 20 is 2 times 10. 10 is 2 times 5. I got a negative 2/5. All right, and y'all are watching all my steps, making sure I don't do anything wrong, right? Depending on y'all. All right, here we go. Let's check out the next one. Number 3. Let's see. All right. Convert to a decimal rounded 2 decimal places. Of course, you could just plug these into a calculator, but the whole point of this is not to, right? We're dividing 7 into 3. So 7 goes into 30, what, 4 times? Is that right? 7 times 4 is 28. It gives me 2. Bring down a 0. To get into 20, I would need twice. That gives me 14. Subtract. Gives me 6. Yeah, I need to know this third decimal place. So let's see, what, 8? 8 times 7, 56. I can't remember my multiplication chart. I'm pretty sure that's right. Subtract, we get a 4. At this point, we can stop because the 8 will turn the 2 into a 3. So this is approximately 0.43. We showed our work, boxed our answer, where it's easy to find and grade. Here we're dividing 17 into 7. So this one, it's ironic. In order to actually do this, I need to use a calculator, right? I mean, if I'm going to use a calculator to see how many times 17 goes into 70, why shouldn't we just use a calculator to see how many times 17 goes into 7, right? That's the irony of math class. 70 divided by 17, I get 4.11 something something. So I know it'll go in there 4 times. And 17 times 4 is 68. There we go. Subtract, I get 2. Bring down the 0. 17 goes into 20 once. 17 goes into 30 once. This will be 13. So at this point, the 1 leaves that 1 alone. So this is approximately 0.41. Now we're dividing a 6 into a 5. Whatever this is, there's a minus sign. Don't forget your minus. A 5. So how many times does 6 go into 50? 8. 8 times 6 is 48, right? Yeah, 48. down to 2. 6 times 3 is 18. One more for good measure. Get another 3 here. At this point, we can stop. The 3 leaves that 3 unchanged. This is 0.83. Let's see if I can remember how to do this. This is 123, is it thousandths, right? Tens, hundreds, thousandths, right? There's really not a lot of work to show here. I mean, we could try to reduce this, but I ain't worried about it. All right, 123, you could mess with that. It could be a prime number. Let's see, 123 divided by 3. Right, if we're gonna show any work, it would be the effort in trying to reduce this. 123, it's not divisible by 2, but it is divisible by 3. Actually, let me do it this way. Here's what I would do. I would say, okay, 123 is 3 times 41. But 1000 is not divisible by 3. It's not divisible by 41. 41 is a prime number, right? Let's see, 41 divided by 3. Yeah, these are both primes, so you can't reduce this anymore. Yeah, so that's it. That's all you can do. That's as simple as it's going to get. This guy here is what? 3, 2, 4, 5, also thousandths. Clearly, these are both divisible by 5. So I would take my calculator and divide them both by 5. So this is 5 times 649 and 1000. 5 times 200. Let's see, 649, not divisible by 3. 6, no, 7. I don't know. We could mess around with this forever. So what I would do is, right, knowing I can obviously pull a 5 out of both of those, I would do that. At this point, I would box both these answers, okay? Because they're both correct, right? It's written as a fraction. Didn't necessarily say simplify it, right? But it's worth the effort to try to simplify when it's obvious that things are easily divisible both by 5. At this point, it's not so easy to see what the prime decomposition of 649 is. It's definitely not divisible by 2 because it's odd. After that, you start trying to divide by all kinds of numbers, and that could waste a lot of time. So that's how I would approach a problem like this in math class. For this one over here, we have negative 175, right? Tens, hundredths. So these are both obviously divisible by 5. So I would divide them both by 5. This would be 5 times 35. And this one would be what? 5 times 20. And at this point, I'd say, well, these are obviously divisible by 5 as well. I get a negative 7/4. So a problem like this is what I'm expecting. I would box both answers though, because technically it does not say to simplify. All right. In my class, I give you credit for either one of these, but some other math teacher, they might be aiming for this. And y'all have a lot of math classes ahead of y'all. All right. Look at number 4 here. Find the unit price. Y'all remember this? We need to find the price per unit. How much how much does one soda cost, right? Is what we're looking for. So if 6 sodas are $7, what we're looking for dollars per soda, right? Dollars per one soda specifically. So if we can get dollars per soda, right? We know it's $7 per 6 sodas, right? We got our dollars, and basically you could look at this and be like, this is 7/6 of a dollar per one soda, right? The way we're interpreting this, we're looking at our units. We want dollars per one soda, right? So use the units to guide you here. So you could say, okay, if you wanted to, I'd box this because 7/6 is decent. Usually though, with money, you want a decimal, right? Rounded to the nearest cent. And 7 divided by 6, right? At this point, I'd use a calculator for sure. This is 1.17 dollars per one soda. This is what they're looking for. This is legit, but nobody ever says $7/6. This is an exact answer, all right? Technically, this is an approximation, right? But nobody cares about fractions of a penny. So this is effectively exact. It's exact to the penny, all right? So either symbol would work here because of the context. Even though it's not exact, it's exact to the penny, and that's all that matters. And then part 2. All right, we need to find the price per ounce. So we're looking for dollars per 1 ounce. So looking at the units, I know I have $12 per 64 ounces. So basically, here's our dollar symbol. This is 12 out of 64 per 1 ounce. All right, so we have our dollars, and we take our calculator, and we say 12 divided by 64, and we get 0.19 per 1 ounce. So it's 19 cents per ounce, okay? I wouldn't, this one, I mean, really, I would not box that, okay? I'd box this, but I'd have this written here. This is your work. This is what you want to show. All right. Anyhow, that's what goes through my mind when I'm trying to get here. A. All right, solve for x. Okay, something like this, because it's a simple fraction equals a fraction. I don't like the x on the bottom. You could do your cross multiplying, whatever. The way I would do this is I'd flip over both sides. Okay. Then, because the x is divided by 2, I'd multiply both sides by 2. So 4 times 2 is 8 divided by 3. So this is the work that I would show. There's other ways to do it, all right? This guy here, to show my work, multiply both sides by 2. So x is 2/5. Of course, you can do this in your head. You can look at that and go, the 2 over there, 2/5. Show one step at least, all right? And again, I know you can do it in your head, but the goal is to be able to write down what you're doing in your head so that you get good at that for when you start to do problems that you can't do in your head. You want to be able to be good at writing down what's going through your head. And we do that with simple examples, right? So this one, yeah, I could easily move the 3 there and the 2 there and be like, okay, this is 3/8. All right. But we have to at least show one step. All right, this dude is multiplied by 2. I'm going to divide both sides by 2. This dude is divided by 3. I'm going to multiply both sides by 3. The 3's cancel, the 2's cancel. The x is 3/8. Same thing we got when we did this in our head. All right, multiply both sides by 3, divide both sides by 2. I'm multiplying that by 3 and dividing it by 2. All right, convert to percents. This guy, first thing you want to do is convert it to a decimal. 2/3 is 0.6666 with a bar over it. That's what it is exactly, right? So this would be 66.6% with a bar over it. You have to put that bar if you're going to have equality. You could say this is approximately 66.66%, because here, once you drop the bar, you're approximating, right? This is the correct answer. That's an exact answer to the percent. It doesn't say round, does it? There's no rounding, right? So follow the instructions as they are stated, right? This is the right answer. This is an approximation, okay? Of course, to get to here, you have to go through here. So if you do this, you still get full credit because you wrote the exact answer down, right? So it doesn't hurt to write the exact answer and an approximation. So whoever's using it has both to utilize. So this guy here, this is going to be easy. This is 65.7%. What work is there to show? Well, if you wanted to show some work, you could go, this is 65.7 over 100, right? Percent. That's pretty much the only step you can throw in there, because that's what this is. Remember the percent symbol? This is basically the abbreviated version of that, per 100. And over here, you have to convert this dude to a decimal. 4/5, 0.8, right? We could write this as what, 80 out of 100. I guess if we're going to show our work, let's see here. To turn this guy into 100, I'd multiply it by a 20 over a 20. This is 80 over 100. We don't even need to put 0.8. This is 80%. We wrote it as per 100. Going the other way. So 22%, what kind of work can we say? This is 22% or per 100, which would be 0.22. This would be 6.8 per 100. So that would be 0.068, right? And we're moving the decimal twice. 0.03%, that's 0.03 per century, which is 0.0003. All right, you don't want to miss the easy problems, because some of these are hard. Number 6. A. Solve for x. Well, we have x's all over the place, right? First, let's simplify a little bit. 2x minus 3x is a negative x. Right, so first thing I combine like terms. Okay, now let's get all the x's to one side. It doesn't matter which side. Since the x's over here are positive, I'm going to put them on the right side. So if I just add x to both sides, I have 1 equals 2x plus 9. So I still want to get the x by itself, so let's get these 9's out of the way. So 1 minus 9 is a negative 8. And now I need to get the x by itself. So I have negative 4 equals x. You could probably do that in your head here. All right. You could probably do it. And if not in your head, you could do it in one step, right? I would be like, okay, I got a negative x. So if I added x to both sides, I'd have a 2x here. And I'd move this 9 over here, which would give me a negative 8 equals 2x. So x would be minus 4. So yeah, that's doable in your head. But this is the work you want to show. There's A. Get B. This dude, fractions suck. The way I would do this, well, let's see. I would collect these x's first, right? I would do this. So that gives me x over 2 equals 4 minus x plus 3x is 2x. At this point, now I get rid of this. I'd say multiply everything by 2. That gives me x equals 8 plus 4x. Then I would, let's see, divide or subtract x from both sides. That gives me 0 equals 8 plus 3x. Then I get the 8 off my back. So I have a negative 8 equals 3x. Divide both sides by 3. And of course, you can always check your work, right? Since it's your final and your grade depends on it, check your work, right? Plug this back in for x and make sure that both sides of the equation are equal, okay? Or you could type this into your program, right? Whatever program you're using, solve, and then type that in, right? Almost all of this math, you should be able to do it with your calculator or a software program. You have to be able to do it this way too, but use your technology to check your work, okay? I'm not one of those people that says, don't use this stuff because that's cheating. No, not using it is stupid. Use your technology to verify your answers. Use it to help you learn and make sure that all this stuff you're doing in your head is correct. Otherwise, you're just going blind, right? Get another one here. Okay, this dude here, fractions suck, right? I might just, let's multiply everything by 3. And again, this is shortcut notation. I'll know what you're talking about, so it's okay. 3 times 3 is 9. 3 times x over 3 gives us just the x, which was the goal there. And then I get a 3x and a 1. All right, combine the x's. Let's subtract x from both sides. All right, so the x's are going to end up over here. So I want the numbers on the other side. So I'll subtract 3 from both sides. 9 minus 3 is 6. 3x minus x is 2x. Divide both sides by 2. So x is equal to 3. All right, you can look at it. 3 over 3 is 1, plus 3 is 4, and 3 plus 1 is 4. So quick check. All right, most of the points that you lose will be lost on stuff that you already know. It's just a simple mistake because you'll have anxiety, you'll be in a rush because it's an exam, you know. So practice will help with that anxiety and help you not make the silly mistakes. Here, I would add 2x and the x is obviously 3x. The first thing I would do, just reflexively. Now let's see, I'll get my, since I have more x's on the right side, I'm going to do that, get my x's on the right, and then put my numbers on the left. So I have a -1, 4x minus 3x is x, so boom, -1. All right, we could check. 2 times -1 is a -2, -1 is a -3. 4 times -1 is a -4, plus 1 is a -3. So I get -3 equals -3. A quick head check. Looks good. All right, here's our conversions. We did this in here, didn't we? I hope we did. Y'all really need to have this. You'll see it again in college algebra if not. It was just the smart one. So like here we have 12 yards, right? Remember we multiply this by the number 1, but we'll do it in a smart way. We want to get rid of the yards and we want to end up with feet. But this has to be the number 1. So we look over here, there's 3 feet in it, 3 feet. How many feet do you have? 3 feet in a yard. So 3 feet is the same as 1 yard. So this is just the number 1. And that makes the yards go away. We have 12 times 3 is 36. We still have units of feet, right? The yards went away. So that's how you would show your work there. I mean, if you know there's three feet in a yard, you just multiply by 3. That's what you're doing in your head. This is what you're doing in your head. Or 2 here, 2 miles to inches. All right, I have 2 miles. I want to multiply by the number 1. Let's see. I don't know how many inches are in a mile, but I know how many inches are in a foot, and I know how many feet are in a mile. So what I'm going to do is I'm going to get rid of miles in favor of feet, and then I'm going to get rid of feet in favor of inches. So there is 5,280 miles. No, the other way around. Try that again. There's 5,280 feet in 1 mile. And there's 12 inches in 1 foot. So I'm left with units of inches. So then I'll use my calculator. I'll take 2 times 5280. Again, my calculator stuck. 2 times 5280 times 12. 126,720 inches. Always write your units, especially a problem about units. You definitely want to write you don't want to write just 36. You want to write 36 feet. Show all your units. This problem is about unit conversion. So show your units for sure. 3 gallons to cups. I got 3 gallons. I want to get rid of gallons and I want cups. How many cups are in a gallon? I don't know. I know how many quarts are in a gallon, and I know how many cups are in a quart. So I'm going to go from gallons to quarts, and I'm going to get rid of the quarts or cups. I know 1 gallon is 4 quarts. And let's see, I know 4 cups is 1 quart. So 3 times 4 is 12, times 4 is 48 cups. Boom. Basic conversion, right? I don't know. Did we cover this too? I hope we did. This is important stuff. It should have covered everything in this class that was in this last class, but more. So if anything, this review should be lacking. We want to get rid of, well, we got 17 kilometers. We want to go to centimeters. It's the same trick. I don't know how many centimeters are in a kilometer. I know how many meters are in a kilometer. And then I know how many centimeters are in a meter. So there's a couple of ways you could do this. All right, I could say I'm getting rid of kilometers in favor of meters. I know it takes 1,000 of these to make one of those. And I want to get rid of meters in favor of centimeters. I know it takes 100 centimeters to make a meter. So I have my centimeters here. So I have 17, and I could look at this, be like, 17 divided by 10 would be 1.7 centimeters. So that's one way to do it, okay? There's other ways you could do, like by substitution. Let's look at this one, 48,960 millimeters. And we want to go to meters. Well, this one's easy because this chart tells us exactly how many millimeters are in a meter. So let's do this one by substitution. This is 48,960, and substitution, millimeter. This is 1 millimeter. 1 millimeter is 0.001 meters. So this one I'm doing via substitution. Okay. I replace this with this. That's what it says right here. 1 millimeter is 0.001 meters, or 1,000th of a meter. So multiplying by 0.001, we're moving the decimal to the left 3 times. So this would be 48.960 meters. And you don't have to have that 0 there. It doesn't hurt if you put it. It's fine with it or without it. Okay. Well, basically, you're dividing this thing by 1,000 because it takes 1,000 of these to make one of those. 980 centimeters, 2 kilometers. All right, let's do this one a little bit different. Instead of writing it like thousands and hundreds, let's write things in powers of 10 because it makes it easier. What am I going to here? Kilometers. I don't know how many centimeters are in a kilometer. This chart tells everything related to meters. So I'll get rid of centimeters in favor of meters. And then I'll get rid of meters in favor of kilometers. Because this chart here says, let's see, centimeters. 1 centimeter is 0.01 meters. That's the same thing as saying 1 meter is 10 squared centimeters. 1 meter is 100 centimeters, right? So I'd say 1 meter is 100 centimeters. And now kilometers, right? 1 kilometer is 10 to the third meters. So I'd say 1 kilometer is 10 to the third meters. So what I have here is 980, which is 10 to the negative 6 kilometers. And this isn't scientific notation yet. Remember, scientific notation, this number has to be between 0 and 1. So, I mean, technically this is correct, all right, but it's not a very good answer. It's not in scientific notation, all right? If you're gonna write it in scientific notation, you would want this to be 9.8 times 10 to the something kilometers, right? And in order to, I always do this. This is, let's see, 980 is 9.8 times 10 squared, right? 1, 2, right? I multiply this by 100, I'd go 1, 2, that would give me 180, and then I'd have a 10 to the minus 16, I'm sorry, minus 6. So this is the step that I would put in here, because I want to turn this into scientific notation. Okay, so I look at that, and I replace it with this, and then I collect my tens. So 2 minus 6 would be a negative 4. So that's it in scientific notation. Or you could put, let's see, if I move this to the left 4 times, 0.00098, is that right? 1, 2, 3, 4 kilometers. All right, these are the two answers I'd accept. All right, this one's correct, but it sucks. Right? You either want it in scientific notation or you want it without scientific notation. I mean, this is correct, but it's just ugly. Okay. I'd take this for full credit. Other math teachers wouldn't. They'd want one of these. I mean, they are all equal after all. Okay. So, I mean, it is correct. Nowhere did it say make it pretty, right? I don't know. I don't know if we did these or not. We should have. You need to be able to convert, right, between your different kinds of temperatures. So we have this formula here that tells us what a temperature in Celsius is given a temperature in Fahrenheit. So this is easy. All we have to do is plug this in, all right? So let's see, for part 1, all right, the temperature in Celsius is 5/9 times the temperature in Fahrenheit minus 32. This is just 0, so I'm getting 0. This is 0 degrees Celsius. Part 2, we have 5/9, 100 minus 32, which is what, 5/9 times 68. All right. I'll use my calculator. 68 times 5 divided by 9, and this is 37 point, well, to be exact, I can be exact here, 37.7. This is 37.7 with a bar over it, degrees. And if you rounded it, you know, I'd give you full credit, but this is an exact answer when you put the bar, right? Nowhere did it say round. It just says convert, all right? And we can give an exact answer, so why not give an exact answer? Let's see here. Part 3. The perimeter of this triangle is 20 feet. Solve for x. Well, the perimeter is the sum of all the sides, 10 plus 6 plus x. There's our setup. If 20 is 16 plus x, right? Subtract 16 from both sides. So x has to be 4. Now you check our work. If I had a 4 here, 10 and 10 makes 20. So easy problem. Now for part B. Evaluate. All right, so we have a minus 5 a is 2. So I'm just replacing a with 2. So I have a minus 10 squared, which would be 100. But you could probably do that in your head, right? 2 times 5, 10 squared, right? The minuses go away. Here, 6, they say x is 1 and y is 2. We have a 6 plus 2 is 8. A plus b squared. So a is 4, b is a minus 1. 4 minus 1 is 3. 3 squared is 9. Let's see. Simplify. All right, so you could do this one in your head with one step, really. I would say this is 5 squared, because the 5 on the bottom cancels this one on top. The a's, we got an a squared b, which would be 25a squared b. This one step kind of shows enough work, right? These are pretty easy. 2, all right, we combine like terms. These parentheses aren't doing anything. They're not doing anything at all. You can just throw them away. Combining like terms, you have 3 plus 2, 5x squared y. 4 minus 3 is 1xy, and then a 5 plus 2 is 7. So let's see, how would I show my work? If I was going to write something to show my work, I would write, this is 3x squared y plus 2x squared y. And then 4xy minus 3xy. And then 5 plus 2. All right, just rearranging them. That's really all you can do, is rearrange them to show that you're combining like terms, right? I mean, that's what this section is testing over, is can you combine like terms? Well, to show that you can, you put them together. Right? Right, if you just wrote this, maybe you just typed it into your calculator. If you wrote this and that, then they know that you know how to combine like terms. Right? So that's what showing your work is convincing the teacher that you know how to do the problem. But it's also helping you collect your thoughts for whenever you can't do the problem in your head, so you can actually write the stuff down. So this one here, let's see, if we would show our work, we'd have the 2x cubed y squared, and then distribute this minus. We got a minus x cubed y squared. Now the x squared y's, I have 4x squared y minus an x squared y. Now I have a minus 3 and a minus 2x. These I can't combine. All right. So these I can. That gives me 1x cubed y squared. These gives me 3x squared y's. Then I would put the 2x first and 3 last. So this problem, can you distribute a minus sign? And can you collect like terms? All right, multiply. We have 2x times 3x is 6x squared. We have a 2x times a 2, so minus 4x. A 1 times a 3, and then a 1 times a negative 2. This is 6x squared minus x minus 2 once you combine your like terms. So that's enough work to show. I mean, you could show more, like with this one here. I would say, okay, I have a 3x times this stuff, and I have a minus 2 times this stuff. Fix this parenthesis here. Right, so I got this times this whole thing, and I have this times this whole thing. So here I get a 12x cubed, and then a 6x squared, and then a 3x. And now over here I get a minus 8x squared, and a minus 4x, and a minus 2. Now I combine like terms. I only have one with an x cubed in it. These I can combine to be a minus 2x squared. These I can combine to give me a minus x. And then I have a minus 2. Part 3. Let's see. Dividing. We're dividing x plus 2 into 3x squared plus 2x minus 5. So to get a 3x squared from an x, I need to multiply it by a 3x. So I put it over here in the x columns, right? And this times this gives me my 3x squared, but I also get a 6x out of it. We subtract. Those cancel. 2x minus 6x gives me negative 4x's. Bring down the minus 5. Maybe I should put this over here. So to get a negative 4x from an x, I need to multiply that thing by a minus 4. So minus 4 times x gives me minus 4x, but then I also get a minus 8. Subtract, right? These will cancel. Minus 5 plus 8 is 3. All right, so the answer here is 3x minus 4, or you have a remainder of 3. We can put a plus of 3 over x plus 2. So here's our work. There's our answer box. We're getting close to the end here. Factor out the GCF. Okay. Let's see. First, we look at the numbers. The biggest coefficient I can pull out is a 2, right? Basically, that's how I do this. To show the work, I'd say, okay, I can pull out a 2. I'll write like this. GCF equals 2. And then let's see, I can get at least one x out of everything. And I can get a y out of everything. So there's my GCF. So I'd say, to show the work without just writing the answer down, this is how they do it in the book. I'd write the first term as 2xy times something. And it has to be an x squared y squared, right? There's the x cubed, the y cubed. And then I write the second term as my GCF times whatever I need. So to get a 4, I need a 2. To get x squared, I need an x. And to get y squared, I need a y. And then this last one, to get an 8, I need a 4. And the x and the y are already there. So since everything has the GCF, I got x squared, y squared. And I need the 2xy here. And then the 4. So that's how you would show your work. most of y'all could probably just write this down, but this is the step that you would want to show your work, basically. So here I would say, okay, what is my GCF? I can get a 3 out of everything. This one doesn't have any X's, so I can't get any X's out, but they all have at least one Y. So I'd say, okay, write everything as 3Y times whatever I need. To get a 9, I need a 3, I need an X cubed, and I already have the Y. The next term, to get an 18, I need a 6 and the X squared. I only have one Y, I need 2 Y's. In the last term, it's a 3Y squared, so I didn't need a Y. So I have 3Y all times a 3X cubed and a 6X squared Y and a Y. Box my answer. Looks like I forgot to box my answer. So number 3, first I find my GCF. I can get at least a 3 out of everything. X's, I can get at least X squared. Y's, I can get a Y squared out of everything. I'd say 3X squared Y squared. The first term, I'd need a 5. 3 times 5 is 15. I need 5 X's. I got 2. I need 3 more. I need 5 Y's. I got 2. I need 3 more. Now for the next term. Oh, this won't work at all. I thought this was a 15. So if that's not a 15, all I can pull, I can't pull a 3 or 5, all right? Because 5 is not divisible by 3. All I can do is an X squared Y squared. So that means that this has to be a 15. This has to be a 5 to get an X cubed. I need an X, a Y. This would be the X cubed and the Y cubed. And we have our X squared, Y squared, and a 3. We have X squared, Y squared. That's 15 X cubed, Y cubed, plus a 5XY, plus a 3. Okay. I probably did this problem, wrote this down wrong. But I mean, it's still good enough of a problem here. What did we leave off? Look at that one. Have to turn on the air conditioner. It's hot. Okay. All right, so for the first one, I can't, if I look at the coefficients, some are even, some are odd. There's nothing I can pull out of everything. These have A's, these have B's. There's nothing I can pull out of everything. So there's no GCF. But when I notice A's here and B's there, I think grouping. So out of the first 2 terms, I could pull a 3A out, and that would give me an X plus 4. So I need to look at this and see, can I turn that into something times X plus 4? If I pull out a 2B, I indeed get the X plus 4. So I have a 3A and I have a 2B, and they're both being multiplied by X plus 4. Part 2, GCF, all these numbers are even. I can at least get a 2 out. Let's see, are they all divisible by 4? No, 30 is not divisible by 4. Not a 5. What about a 6? No, 16 is not divisible by 6. 8. No, I know I can get a 2 out. And everything has at least one W in it. So let's pull out this 2W first. That gives us 8W cubed minus 20W squared minus 6W plus 15. All right. So now let's look at these guys here. I could try grouping. Let's try grouping. The first two terms, I could pull out what, a 4W squared, and that would give me a 2W minus 5. And then I look at this, can I turn this into something times 2W minus 5? If I pull out a minus 3, that'll give me the 2W. And it turns out I also get the minus 5 here. So I have a 2W. I got the 4W squared and a minus 3, and they're both multiplied by a 2W minus 5. This point, you might see there's a W squared. Can I factor this? Well, not into pretty numbers, you know? Like if this was a 9, this would be the difference of two squares, right? I mean, technically this is root 3 squared. Like you could factor this guy into 2W minus root 3 times a 2W plus root 3. But when they say factor, what they really mean is where these numbers are whole integer numbers. So they don't want you to factor this. They want you to leave it like that. Because again, if you factored it, you get root 3's in there, and that's just ugly. And let's see, number 3. This one, I don't know if there's a lot of work we could do here. Basically, this is an eyeball method one. You put an X and an X, and you just write a 3 and a 1. All right, I guess you could check your work. You could be like, okay, this is X cubed plus 3X plus X plus 1. Right? Show that this is 4X. So really the only work you can do here is check your work, because these you do by eyeball. When there's no coefficient out front, this is, you eyeball it. We have 2 problems to go, and we'll get out of here early. All right, factor. This is one that we'd eyeball because there's no coefficient here. We need a Z, we need a Z. We need 2 numbers that multiply to give us 48, but add to give us negative 16. If they're going to multiply to be positive, but add to be negative, obviously they both have to be negative, right? So we start thinking, what do we have? 8? What is 48? 8 times 6? I can't remember my multiplication. Yeah, 8 and 6 give us 48. So the only work to show here is be like, what are the numbers that multiply to give me 48? Those don't add to give me 16. Those don't add to give me 16. That's 16 and 3. Those don't add to give me 16. 48 and 4. 12 times 4. Those multiply to give me 48, and they add to give me 16. So this is the only work you could really show for this problem, other than multiplying these out to check your work. Right? Let's look at 2 here. Notice one, this thing is out of order, so we want to put it in descending order. Also, we can pull out a 10 as well as a t. So let's pull out a 10t first, and then put this thing in the correct order. This gives us the 10t cubed, and then we would have a minus 3t, and then a minus 4, right? Is the minus 4t. We have a 10t. This dude we can eyeball because there's no coefficient. We know we need a t and a t. We need two numbers that multiply to give us -4 and add to give us -3. So how about a -4 and a +1? They multiply to give me -4. I got the -4t plus t gives me the -3t. This one, let's pull out a GCF. I know I can get a -3 out of everything. That would give me an a squared minus 5ab plus 4b squared. So since there's no coefficient here, we should be able to eyeball this guy. I know I need an a and an a. This has the b squared and there's b's there. I know I need a b and a b, right? Now for the numbers, I need two numbers that multiply to give me 4, but add to give me -5. If they're going to multiply to be a positive, but add to be a negative, they both have to be negative. And we're looking at a 4 and a 1 here. Of course, we don't write the 1, right? There's the positive 4b squared. There's a -4ab and another -ab, which gives us our -5ab. So that's it. We are done with that one. All right, factor. So this is just a reminder of the difference of two squares, right? This is to show your work. All you could do is really write 25 is 5 squared. So this is y minus 5 times y plus 5. Box your answer. This guy, we can pull a 2 out. And then we can write the 16 as 4 squared. So you have the difference of two squares. So there's all your steps, right? GCF, write as difference of two squares, apply your formula. This one, difference of two squares. This is w squared squared, and 81 is 9 squared. So this is w squared minus 9 times w squared plus 9. This is the difference of two squareds again. W minus 3 times w plus 3. And this dude over here is the sum of squares, which we can't do anything with. Right? If you tried to factor that, you would get imaginary numbers. Remember, I is the square root of -1. So you could rewrite w squared plus 9 as w squared minus 3i squared. The 3 squared would give you a 9. I squared would give you a -1. That cancels that minus. It gives you a plus. So this would be a w minus 3i times a w plus 3i. But in this class, we're not using imaginary numbers. We'll save that for later. But I want you to see that, all right, because y'all are going to be scientists of some kind. And you're going to use imaginary numbers constantly. That doesn't hurt to catch a glimpse. All right, here we go. This is easy, graphing points. One, two, go. Let's see, I'll move this. Go over 1, go up 2. Boom. Back 2, up 2. Boom. There's I. There's 2i. Over 3, down 2. So here's the I. And then back 2, down 3. So there's your IV. Boom. Are these solutions? All right, well, replace the x with the 2 and the y with the 0. I'll say left-hand side is equal to that, which is 12, which is the right-hand side. So yes. Part 2, left-hand side is 6 times 3 minus 5 times 1, which is 18 minus 5, which is 13, is not the right-hand side. So no. And part 3, the left-hand side, replacing x with 1 and the y with negative 6/5. 6 times 1 is 6, a minus times a minus is a plus. 5's cancel, that's 12, and that is the right-hand side. So yes. Graph. Y'all need to be able to graph. So if I'm going to graph and do it right, here I see my m is 2, my b is 1. So my y-intercept here, right, is 0, 1, right? If I let x be 0, then y is equal to 1, right? It's a y-intercept is 0, 1. That's what the b tells me. Slope is 2, which is the same as 2 over 1, or negative 2 over negative 1. It's your rise over run. This says go up 2, go to the right 1, up 2, go to the right 1, up 2 to the right 1. Or I can go down 2 and to the left 1, down 2, left 1, down 2, left 1, down 2. So this is not a complete answer. You need to label some points. This is 0, 1, right? This point here would be what? -1, -1. This is x, this is y. And you need some scale. I put right here, like, this is 3. So I know that we have some scale. I'd say, well, then this is 3. All right. Really, labeling these points tell you the scale. This is a little bit extra. If you're really going to be like thorough, you want to have scale left and right and label it at least 2 points, because it takes 2 points to make a line. Definitely label this one. Really, let's see. Yeah, that's good enough. There's C and D. All right, it's already in mx plus b form. So m here is 3, 3 over 1, or negative 3 over -1. B is -2, so your y-intercept is 0 minus 2. If we do our thing here, we would have, I'll make this black. Boop. 0 minus 2. My slope says go up 3, go to the right 1, up 3, right 1, up 3, right 1, or go down 3 and left 1. So here's my line. This point is 0 minus 2. This is what the most important point to label, right? It's the one that's given to you right there. So obviously label that one. After that, it's kind of arbitrary, right? This point here would be over 1, up 1, right? We could say, okay, here's 3 and here is 3. X-axis, Y-axis. There, it's thorough, right? So there's your answer. And that's it. I'm sure there's more stuff that I didn't cover in this review, but it's the majority of it. So next time we're going to go back to chapter 2, and we are going to work random problems from all these sections. What we're going to do till the end of the semester to drive this stuff home, okay? And that's it for today, folks. Any questions? All right, I'm gonna upload this. And I've named it, you can see up here, finally, it's lecture 23, but I have the dash in there. So remember that I'm having to put these in that new folder, right? Because for some reason, Canvas only allows me to put 20 files in a folder. So you'll be able to find this review here under more lecture notes, okay? Study it and work as many problems as you can. And don't forget about the tutoring lab. Make sure you do all the exams and quizzes, even if they're late. How are they? Yeah, the way I'm going to do it is under assignments. You'll have like the daily quiz and the daily exam sections. I'm going to have a whole section called final exam. And so you will upload one file per problem, okay? Basically. So you can see it just loads. There. So you see how there's daily quizzes and then there's daily exams. I'm gonna make another subgroup called final exam, and there'll be a problem number 1, a problem number 2, and a problem number 3. So for each problem, you'll upload things separately. That way I can go through and grade them per problem. And then on each one of these, it'll be worth 10 points. Each problem will be 10 points. Keep track of the hours for the lab. This lady emails me. I don't keep track of them. I mean, it really doesn't matter. You're here to learn this stuff, not to count your hours in the lab, right? I know people that go to tutoring 40 hours a week and don't learn anything, right? So don't go to the lab just to get hours in the lab, all right? Go to the lab to learn this stuff, okay? But yeah, I do get a report from the lady. I'm supposed to grade y'all based on the time you spend there, but I'm just giving you the full 5 points. Everybody gets the full 5 points. I'm going to assume that you've all spent enough time there, because I think it's just totally lame to have points for appearing to try to learn, right? That's not what a grade is supposed to represent, right? It's supposed to represent how well you've mastered the knowledge, right? So whether you didn't go to the lab and you learned everything, or you went to the lab and you learned everything, or if you went to the lab a whole lot and didn't learn anything, right? The lab is just a tool, right? Just like a calculator. I'm not going to keep track of how many hours you used on your calculator or give you points for every button you pressed on your calculator this semester, all right? The lab is a tool. You utilize it. It's one of the most valuable tools you have. They're there all the time. You can even zoom in, okay? And they'll help you. So work the daily quizzes and the exams, uh, study the review, work random problems in the book. Basically, I'll just need to spend time practicing this stuff so that your neural networks get rewired so that this becomes reflex. All right, any other questions? Oh, I totally forgot about the daily exam, didn't I? Nah, I guess we won't have one today because I forgot. Okay. And I'll just give everybody full credit for today's exam. Okay. All right, any other questions? You're welcome.